Okay, guys, happy Wednesday. Let's get situated. I'm going to do this lesson, and then uh, when we come back after Christmas break, we'll have a review and then a quiz on these final three lessons. But it's equivalent expressions, chapter 6, lesson 7. It's the last lesson. It's an excellent lesson. We'll go back through all this again, but we need to keep rolling through. So let's go ahead and get circled up here. Excuse me, on the homework, and make sure that we're in good shape here. We're going to go 1 to 14. Okay, so let's just go ahead and circle, please, these problems 1 through 14. We're going to need a calculator today. We're going to be doing some factoring, which is nice. And there. And then we're going to jump to numbers 18 and 19, right? 18 and 19. And I'll probably end up doing those with you today. And then we're going to go 22 to 34. So let's go ahead and circle those. And then let's jump into this lesson because it's a good one. It's a good one here, okay? All right, let's go ahead and flip it back and get right into the guided practice. I'm going to talk to you a little bit about some vocabulary here. And I'm going to do that actually on a separate sheet of paper because I need to make sure that we're in good shape here and we understand what we're talking about. And I can do it better on a piece of paper here. So let's go. Okay. So first up, we have some vocabulary here, okay, and I'm going to go ahead and write an expression down. I'm going to write it as 3x plus 7 plus x, okay, and that plus doesn't well, it looks like an x, so let's change that there. Okay, so let's define a few things. Last week I talked to you about the number before a variable, right, and that number before a variable is called a coefficient, right? And a coefficient tells us how many. It means this number times that variable. The variable here is x, variable, and you don't really need to write this down. Just kind of listen. So this is the coefficient. That's a variable. Now, what is the 7? The 7 is what we call it's constant. It doesn't change. It never wavers, right? So it's constantly 7. The only way I can change it is by adding, subtracting, doing an operation, right? And then finally, again, that x is a variable. All right. All right. Now, what we have to understand is the whole thing is encompassed by calling them terms. All right. These are all terms. This is a term. That's a term. That's a term. These are like terms. So we could actually combine those and simplify it. Right? And if we wanted to simplify that down, all right, 3x plus x. And by the way, what is the variable in front with what is the coefficient in front of the variable there? There's actually a 1 there. So 3x plus x, or 1x, if we simplified this down, would be 4x plus 7. This is actually equal to that, okay? So coefficient, variable, constant, again, another variable, and a variable is any lowercase letter in the alphabet, but they're all three what we call terms. So they are, okay? All right, so let me put that to the side. Let's get back into this. Okay, so simplifying expressions. All right, so we have a constant, a coefficient, and a variable. So here's the rule. You are allowed to multiply unlike terms, but you're not allowed to add and subtract. And you're going to see how this varies here, okay? So we can go ahead and multiply 5 times 6 and get 30, and we bring the x along for the ride. So this is actually equal to that. That is simplified, okay? Number 2. Now, number 2 is a little bit different because we have a 2x and 7x, and you're going to notice that I underline the x's and I circle the y's. Now, I can combine these. And again, to combine like terms, you have to be adding or subtracting. So 2x plus 7x is 9x plus 5y. Now, here's the difference. Here we can multiply, all right, unlike terms or like terms. Here we can only add or subtract like terms, and that's why I underlined both of those, okay? And you're going to see how that varies here. Number 3. Number 3 is a little different because now it's 4 times the quantity of 2x plus 5y. And actually what we're going to do here is we're going to use the distributive property. Okay, and we learned that last week. But we're going to distribute that 4 through. So it's going to be 4 times 2, which is 2x, plus 4 times 5y. And remember, I called that our second level. So 4 times 2x is 8x, and 4 times 5 is 20, and bring the y along for the ride. And that is simplified. We're not allowed to add unlike terms, but we are allowed to multiply a constant and a coefficient there. So 3 very good examples, and I'll get into the next page with you a little bit more to do some more samples with that. Okay, now we have this word called factor. Okay, and we're going to factor. What are we going to do here? So what we have to do is actually we want to try and write this like this. And what we're going to do is use our calculator to find the GCF of those numbers. So I'm going to go to the math button, come down to GCD and hit enter. And what I'm going to do is enter 35, and I'm going to separate them with a comma, and then I'm going to enter the number 28. All right, and then I'm just going to hit enter. And I found out that the GCF of those two numbers is 7. So what does that mean? The biggest number that goes into both of those is 7. So 7 times the quantity. 35 divided by 7 is 5. Bring the x along for the ride. Plus 28 divided by 7 is 4. Bring the y along for the ride. So this is factored. We factored out a 7. We essentially divided both of these by 7. Okay, let's press and pause here a little bit. So we talked about a lot so far, haven't we? We talked about multiplying unlike terms, a constant and a coefficient, combining like terms when it's addition and subtraction, multiplying 3 using the distributive property here. And again, we can multiply unlike terms, but we can't simplify it any further than this. And then we talked about factoring, dividing both numbers by 7, right? So that's been pretty good so far, all right? Okay, now let's jump into the next one here, number 5. Michaela bought, 5 skirts at X dollars each, okay? 3 of the 5 skirts came with a matching top for an additional $9. All right. Write and simplify an expression that represents the total cost of her purchase. Okay. So let's go ahead and get into this thing and see what we have here. Okay. All right. 1 second here. I'm having a computer glitch and I need to make sure I'm squared away here. All righty. Here we go. All right. So we need to write this expression, and I want to make sure that we're okay on this. All right. I'll just maybe bring that in just a little bit more. I was trying to bring that in a little more. It's not working too well. Okay. Here we go. So if she bought 5 skirts at X dollars, 3 of the 5 skirts came with a matching top for not an additional $9. Right? Write and simplify the expression. So if we bought, 5 skirts, all right, for X dollars each, right? So what I see is 5 skirts for X dollars is 5X. That's what I see, right? And then 3 of the skirts came with a matching top for another additional $9, right? So when I look at that, 3 of the skirts came for additional $9, so 3X plus 9. Okay? So we're looking at this. We have 5X and the 3X plus 9. And if we go ahead and simplify that, we end up with 8X plus 9. All right? Let's flip the page here and get into the homework a little bit more. The word problems are going to be difficult, and I will warn you of that, okay? So take your time with them. Okay, let's start and let's do maybe 1, 4, 7, 9, and 11. Okay, number 1, I'm going to combine all of my like terms. X, 5x, 11x. Okay, they're all like, so we can just combine them. Number 4, 3x and 13x. And then the 8y is going to stand alone. So we end up with 16x plus 8y. I combined it. Factoring. Now, I'm not going to use my calculator this time. I'm just going to say that, hey, the greatest number that goes into both of these is 6. And I like to write it underneath. So it's 6 times the quantity. 24 divided by 6 is 4x, plus 18 divided by 6 is 3y. Right? And that's what we have. I divided both of these by 6 and brought the variable along for the ride. 8 friends went to a hockey game. The price of admission per person is X dollars. I don't know what it is. It's X dollars. 4 of the friends paid an extra $6 for each of the friends to for 4 of the friends paid an extra $6 for a player guide. Write and simplify an expression. Okay, so what do we have here? All right, 8 friends total went. All right, so we know we have a total of 8. The price of the admission per person is X dollars. 4 of the people paid $6 extra. Okay, so we should have 4 times the quantity of X, right? So they're going to pay X dollars per admission. Plus, 4 also paid $6, right? But we have a total of 8 people, right? So we need that. They also paid the X dollars to get in, but they did not buy a player's guide. So we're going to add 4X at the end. Why? Because we have a total of 8. 4 and 4 is 8. So now we need to distribute through this problem. And this is going to be 4X. 4 times 6 is 24 plus 4X. Now I'm going to combine my like terms. 4x and 4x is 8x. Okay. And I'm going to leave my constant the same. Okay. So very good question. Very good question. I have a total of 8 people paying the admission. Right. 4 of the people paid an extra $24 to get a player's guide. That works. Number 11. Number 11 reads, a DVD box set includes 3 thriller movies and 2 comedies. Okay. Use T to represent the cost of the thriller and C to represent the cost of the comedy. Write and simplify an expression. Okay. A DVD box includes 3 thrillers. All right. And now what does it represent for a total box set of 6? Okay. All right, well, let's go to work. So if we have 3 thrillers, I know I have 3T plus, and if I have how many comedies do we have here? We have 2 comedies, right? So we have 2 comedies, 2C. So 3T plus 2C, but that's 1 box set. I need 6 box sets. So now we're set up. Now we're going to go ahead and distribute through. You see the 3T, the 3 thrillers, plus the 2C. This is 1 box set together, but I want 6 of them. So 18T plus 12C. See, I distributed through. We can't simplify it further anymore. Okay. All right, guys. Well, that was a pretty long session today, pushing 15 minutes here, but I hope that helped you. And you can kind of go from there.